About a year ago, I promised that I'd tackle the topic of range cards and how to make them. All these months later, I find myself sitting outside an old abandoned horse racing track, thinking to myself, where the heck do I even start? But on a more serious note, yes, we are going to take a look at these range cards, and I'm going to run you through the whole process of how I make them. But I'm going to break this tutorial into two parts to make things a little bit easier. In this video, we'll take a look at how to make the cards, and in part 2, we'll take a look at ballistics calculator apps that you can get on your smartphone and how they compare to the cards. But before we dive straight in, I just want to clarify one or two things. First of all, I am an air rifle enthusiast, which means I'm going to be using air rifles in all of my examples. But the exact same principles apply to rimfires and centerfires. So if you shoot a full bore rifle, this video can still help you. Secondly, if you are an air rifle shooter, but you're shooting with an entry-level air rifle that isn't able to hold tight groups, let's just say, for example, you're not able to hit a coin consistently at 25 meters, then you're probably just going to get frustrated trying to do this, so this video may not be for you. But anyway, let's get to it. The first thing you'll need to do is to download Hawk Chairgun Pro from the Hawk Optics website. This is ballistic software in which you enter a few variables and it'll plot out a graph for you. This is available on Mac, on PC, on iOS and on Android, so you can take your pick. The next step is to gather all the required information. So here's a list of what you need. We'll go through these one by one. Firstly, muzzle velocity. The only reliable way to do this is using a chronograph. You can use applications like Chrono Connect on your smartphone, which uses sound to give you an estimation. You can check on the forums to see what velocities others are achieving, but you're never going to be sure unless you crony that rifle yourself. And small discrepancies are big discrepancies when it comes to long range shooting. Next, pellet weight and ballistic coefficient. Once you've got chairgun, this is quite simple because there's a whole pellet database. You just choose your pellet and the program does the rest for you. We won't cover the science behind the ballistic coefficient now, but it's important, and chairgun's values are pretty accurate. The zero distance is exactly that. It's the distance at which your rifle is zeroed. It's plain and simple. We're not going to waste any time on that one. Scope height, again, very important, and there's a very specific way of measuring this that most people seem to get wrong. The scope height is the distance between the center of the barrel and the center of the scope. Here's an easy formula to help you measure. Half the barrel diameter plus half the objective lens diameter plus the distance between the barrel and the objective lens. And the last thing, air density. Now this is where things get complicated. You can estimate the air density by entering the temperature and the altitude into chairgun, but as I've become more and more critical of my results at long range over the years, I've realized that this isn't always completely accurate. There's only one way around this, and we'll get to that in part 2 when we compare the cards to the calculators. For the sake of this demonstration, let's just leave it at default, which is sea level 20 degrees Celsius. So you've entered all this information, now what do? Well, there's an easy way and there's a hard way. The easy way is to go to Toolbox, Range Cards, and select the units you want, but this isn't ideal because the wind and the incline angle aren't included. So if you're willing to spend a little more time, you'll probably want to make something like this. This is a very comprehensive card. It gives you options for both wind speed and incline angle. So it's as simple as reading your conditions, finding your holdover and windage values, and adjusting accordingly. Now this is time consuming because you'll need to create a table on a spreadsheet document and you'll need to fill in all those values manually. I think it's completely worth it though to spend a few hours doing this properly. You won't regret it when you're out in the field. You may want to create a few different cards as well. For example, I've got one in milliradians or MRAD, the unit of measurement that mil dots are named after, and I use this one for holdover shooting using the reticle. The downside of this is that if you're using a variable power second focal plane scope, you'll need to print a new card every time you change the magnification. I've got different cards for different magnifications. You can also use different units of measurement. This one is in minutes of angle, and it allows me to make adjustments on the turrets of my scope instead of holding off. When possible, I way prefer using the turrets because I can shoot at any magnification and it doesn't change the point of impact. And lastly, if you travel a lot like I do, you might need different cards for different air densities. I live at sea level, but I hunt a lot in the mountains where the air is much thinner, so if I pack the wrong cards, I'm going to end up shooting way over or way under that animal. So that is more or less how I make my range cards. The method is straightforward, but the theory is a little bit more complicated. The cards will make things a little easier out in the field, but they obviously have the disadvantage of being specific to certain conditions. In part 2, I'll show you how I overcame this hurdle with the use of technology. If you want to know my deepest, darkest secrets, stay tuned for the second part. I'll put a link right up here when it's done. Thank you for watching, guys.